Hello once again, my name is Thomas and this is going to be my second demonstration project for MTH 155 Statistical Reasoning. Today I'm also using OBS Studio as before. This is free and open source software and it allows you to customize how you capture and mix audio and video from different sources. It's very useful. So today I'm going to be reviewing a question from Chapter 7, and this question states that the table below lists brain sizes in cubic centimeters and IQ scores of subjects. Complete parts A through D. We're given a table with all of this data, and our usual pop-up that allows us to copy the data into StatCrunch, our clipboard, and Excel. So part A asks, how well does the best fit line actually fit the points in the scatterplot? Construct a scatterplot and draw the best fit line. Choose the correct graph below. So we're going to open this up in StatCrunch. It's going to inject the data automatically. We can go to graph, scatterplot, x variable will be brain size, y variable will be IQ score. To get our best fit line, we're going to select this option, overlay polynomial order, and select 1, and click compute. This will give us a graph. We can adjust the x-axis and y-axis to be the same as what's given in the examples to the left, or the choices I mean. I like to do that just to help create the best visual comparison possible. Makes it a little bit easier. So you can see that the line goes slightly above the first point, slightly above the last point, and the only graph that does that actually is going to be graph D. And the rest of the dots match up pretty well, so I would say that that would be the best choice. And it is. So part B asks us to briefly discuss the strength of the correlation, compute r and r squared. Based on the value for r squared, identify how much of the variation in the variable can be accounted for by the best fit line. Now to do this, we can also use StatCrunch. Very useful. We can go to regression, simple linear, x variable brain size, y variable IQ score. Click compute. This gives us a pop-up with several data points. The ones that we care about are going to be r and r squared right here coming up. So the correlation coefficient is going to be 0.38, and that's correct. And then r squared just beneath it is going to be 0.14. Based on r squared, what percent of the variation can be accounted for by the best fit line? All you have to do is convert this decimal into a percent, which we do by multiplying by 100 to give us 14. And then it wants to know if there are any outliers in the scatterplot. And so this can be done just by roughly eyeballing it. The one that stands out to me the most is going to be this data point right up here, which is 1044, 136, which is option C. And then the last part of the question asks us, does the best fit line appear to provide reasonably reliable predictions within the range of the given data? Explain. Now, the best fit line will give us a prediction that is usable and reliable if it's a high percentage. This is a rather low percentage on a scale from 0 to 100%. So, because that's so low, I'm going to say that there's little correlation, which is going to be option D down here. Predictions based on the best fit line could not be reliable because the value of r squared means there's little correlation, which is correct.